Okay, so converting radicals to rational exponents. Let's remember what the word rational means. The root there is ratio. So ratio should make you think fractions. So we're going to look at radicals and fractional exponents and their relationship. So let's look at a few examples here. We're going to take these radical expressions here and we're going to write them in exponential form. Parentheses are very, very, very important and essential when it comes to this. So noting where the parentheses are means a lot. Now, what we're going to use here is, I refer to it as power over root. Okay, power over root is the relationship to be able to put this in exponential form with the rational exponents. So, if we look at this expression right here, the entire radical here is being raised to the fourth power, so that's the power, and the third is the root, it's the cubed root. So if we write this in exponential form, we need to put parentheses around the 6x and raise it to the 4 over 3 power. Okay? Now B is a little different. Okay, B is a little different because the power of the 2 there is only on the m. It's not on the entire radical expression. So when we write this, the entire expression here really is only being raised to the first power. So what we've got is 4m squared raised to the 1/3 power. Now, you could use your exponent rules to apply that power. So you may also see it as 4 to the 1/3 m to the 2/3. Okay, that's the difference between example A and example B. Example A, the 6 and the x have the same power. Example B, the 4 and the m have different powers because of the exponents. Okay, let's look at C here. We've got a fraction in addition to our radical expression. So let's deal with putting it in exponential form first. Okay, this is another example of where the entire expression 5x is being raised to the 5th power. So the root is the 3rd root, so that's the 5/3 power. And at this point, if it was multiple choice question, you'd look at your answer choices to see what form they're in, but a lot of times we're going to move this using our exponent rule. We're going to move it out of the denominator to the numerator with a negative exponent, okay? So that would be 5x to negative 5/3. Okay, so that's just an exponent rule. Okay, example D, we've got 8. I'm sorry, do you have a question? My bad.
If like that one would be a 2,
Yes, yes. So like we've got here in example D, we've got 8 over the cube root of 8x squared. So let's write the bottom in exponential form. So again, this is the example where the entire expression is not being squared. Only the x is being squared. So the entire expression needs to be raised to the 1/3 power. And in this case, I'm going to go ahead and distribute that power because we can use 2 exponent rules here. We've got a base of 8 in the numerator and in the denominator, so we can subtract. So that would be 8 to the 2/3 power. 1 minus 1/3 is 2/3. And then the x, we move it using our negative exponent rules. So it has the negative 2/3 power. Okay. So a reminder of your exponent rules and then the radical to rational exponent properties. Okay, so practice with these 2 problems here. And then I've got some just reminders. therefore converting form.